Okay, so this video is about linear dependence and independence of vectors. You'll be able to, at the end of this video, define what linear dependence means, define linear independence, check if 2 or 3 vectors are independent. So that's our plan for today. A group of vectors are linearly dependent if one of the vectors can be expressed as a combination of the others. They're independent if none of the vectors are combinations of the others. So none of them are linear combinations of the others, independent. Now let's look what that means. Here's two vectors in 2 dimensions. And you can see a pair of vectors are linearly independent if they're not parallel. So we look at the ones on the left hand side, and there's 2 vectors which are parallel. If they're parallel, then they're linearly dependent. One is a multiple of the other. If they're not parallel, then they're independent. So linearly independent. The next situation is when we've got 3 vectors in 3 dimensions. So these 3 vectors, they all lie on the same plane. That is, if you put their tails together, placed at the origin, then they would all lie on the same plane. So as soon as you've got, have a look here, I'll put them all together, tails together, and they all lie on the one plane. So that means they're linearly dependent. I've got 2 dimensions and 3 vectors. If you have more vectors than what you have dimensions, so more vectors than dimensions, then there's always linearly dependent. Okay, what if we've got 4 or more vectors in 3 dimensions? Well, as soon as you've got more vectors than you have dimensions, then you've linearly dependent. So 3 vectors in 2 dimensions or 4 in 3 dimensions. Now let's have a look at our problem. Are these 2 vectors linearly independent? A is I minus 3j, B is minus 2i plus 6j. What we're trying to do is find, is one some sort of linear combination of the other? So B equals minus 2 times I plus minus 3j. I take out minus 2 as a common factor. What do you notice? I minus 3j is the same as A. So B is a linear combination of A. Therefore, these are not independent. These are linearly dependent vectors. Okay, so that's the concept: linear dependence, linear independence. They're dependent if one is a linear combination of the other. Okay, and we're going to stop now.